Okay, so right triangles are very, very special. You saw two special right triangles over the last couple of days, 45-45 90s and 30-60 90s. And we use those triangles to help find side lengths. We can find side lengths of any right triangle using trigonometry. And so I put up here that the study of trigonometry involves triangle, specifically right triangle measurement. I can find an angle measure in a right triangle or a side length measure in a right triangle, so long as I have two things in that triangle, either two sides or a side and an angle. It won't do me any good to know just two angles though, so I have to have at least one side. And the purpose for using trig is to measure things that are huge, too huge, to use like a measuring tape with. So for instance, if I wanted to measure the distance across the Great Lakes, one of the Great Lakes in Michigan, am I going to be able to get my little boat with a tape measure and have somebody hold that on the other side and me travel along in my boat and go measure the other side? Don't think they make tape measures that long, because those are huge. And perhaps the purpose for me needing to know the measurement of the lake is because I might need to find the volume of the lake, because I might need to, I don't know, restock it with fish. Or maybe I need to find the height of a really, really tall building because I need to get paint for it or various other materials for it. There's a lot of reasons for me to have to find the height of things. I've had my husband shot off rockets in the football field before. If I can talk him into it again, we might do it fourth quarter. And we were able to find the height of rockets using trigonometry. Am I able to actually zip up with a rocket with my tape measure and find the height of it? No, that's not feasible. So we have used mathematics to find heights or distances of things that are not easy to find. And so that's really the purpose of trig. So the next thing you have on there is that a trigonomic ratio is a ratio of the length of sides of a right triangle. And isn't that what we've been doing all week? We've been using ratios to length of sides, whether it was a geometric mean or whether it was the 45-45 or the 30-60-90 triangles. The most common and the ones that we're going to work with are sine, cosine, and tangent. There are 21 trig functions altogether. We're starting with 3. And we abbreviate these here. And so you've got the table in front of you. I've got a picture of the triangle over here. And I've labeled the angles with capital letters and the side lengths. So the side opposite angle A I've labeled with little a. The side opposite big B is with little b, and the side opposite big C is little c. And big C is your right angle. So you need to learn these, memorize them. I'll give you an easy thing to memorize them with. Sine of angle A, so here's angle A. This is called your angle of reference. It's abbreviated as sine A, without the E. It's the leg opposite of angle A, or it's the hypotenuse. So what's the leg opposite angle A? Side A, right? And then the hypotenuse is C. The hypotenuse is always the longest leg. It's always across from the right angle. So sine is defined as A over C. For any right triangle length, the ratio of A over C will be the same no matter how big this triangle is. If I have whatever degree this angle is, maybe it's a 51-degree angle, the ratio of A over C will be exactly the same for any similar triangle that has a 51-degree angle here and it's a right triangle. Remember we did a whole unit on similar triangles? So we were able to get these ratios using our knowledge of similar figures. Cosine is abbreviated COS, and cosine is the leg adjacent. So if this is my angle of reference, angle A, what leg is adjacent to A? Leg. Is it C or B? Isn't B the leg? Even though this is adjacent, and if a lot of you don't know the word adjacent. If I said to you, go get a cup of sugar from your neighbor that's adjacent to us, would you go across the street or would you go to the person next door? Next door. So adjacent means they're right next door, they're touching you. So with angle A, it's actually got two sides that are touching it, right? But notice that I said leg, not the hypotenuse. So it's the leg adjacent B over the hypotenuse. Hypotenuse will nearly always, for sine, cosine, tangent, be in the denominator. You'll learn some inverses, and then that'll change. But for right now, tangent is abbreviated tan, and it's the leg opposite over the leg adjacent. So again, this is still my angle of reference. Leg opposite is what? A, and leg adjacent is B. Now, if I change my angle of reference to B, so you can kind of put this down at the bottom, watch what happens. So if I change my angle of reference to angle B, and I want to know what's the sine of B. Sine is opposite over hypotenuse. So what leg is opposite B now? B. And what's the hypotenuse? C. So the ratio here would be B over C. It's not A over C because I changed my angle of reference. So again, if I want to find the cosine of B, cosine, here's my angle of reference, is leg adjacent over the hypotenuse. Here's my angle of reference, which is the leg adjacent. A or C? A, and then you would put it over C. So now I have A over C. Isn't the cosine of B the same as the sine of A? And isn't the sine of B the same as the cosine of A? So it's an interesting phenomenon. And then your tangent of B would be what? Here's your angle of reference. Opposite over adjacent. What's the opposite? B. And what's the adjacent? A. Aren't these reciprocals of each other? Okay. So sine, cosine, and tangent will change depending upon your angle of reference. So how are you going to remember all this? Anybody learn anything for sine, cosine, and tangent? Have you heard of Sohcahtoa? Sounds like an Indian name, doesn't it? Sacagawea? Sohcahtoa? All right, so this is what you're going to do. You have to know how to spell Sohcahtoa, though. Okay, this is Sohcahtoa. Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, opposite, adjacent. Sohcahtoa. Now how are you going to remember how to spell that? Here you go. Are you ready? Don't complain to your parents about what I'm about to say. Some parents will be so picky about this. Some old hippie caught another hippie tripping on acid. Yes, we're talking about drugs. All right, so write that down. This is how you're going to remember how to spell it. Some old hippie, S-O-H, some old hippie, caught another hippie, C-A-H, tripping on acid. Kind of catchy. Some old hippie caught another hippie tripping on acid. So the very first thing I would do if I were you when I'm taking a test over trig is I would write Sohcahtoa up there. And to help you remember Sohcahtoa, that's why we did some old hippie caught another hippie tripping on acid. Now I'm going to tell you right now that you're going to have an extra credit opportunity sometime in the next 2 weeks to come up with your own acronym. And it may not be some old hippie caught another hippie tripping on acid. So if you don't like that, you can come up with your own. And it's possible it could be an extra credit opportunity based upon that. So there's the fun for today. Now, let's go ahead and apply this. So I also put here for you that the trigonometric ratios are related specifically to the acute angles of the right triangle. Notice that I never talked about angle C, right? And we're not going to. So it can only relate to the two acute. All right, then we're going to look at, so I'm going to switch sheets here. We're going to look at our fraction equivalence here. So You are to find the sine of A, the cosine of A, the tangent of A, and then the sine of B, cosine and tangent of B. And I want you to express each ratio as a fraction and then as a decimal. So we're going to start with a fraction and then the decimal. So I gave you all a calculator, right? Make sure when you're taking your test you pay attention to whether I said fraction or decimal, because it's important. So I don't know what angle A is, and I don't know what the measure of angle B is, but I can find the sine of this angle measure based upon these measures here. And I can't just put any measures here on this right triangle. Don't they have to meet or pass Pythagoras' theorem? So you need to trust me, and if you don't, you can plug it into your calculator, that 5 squared plus 12 squared equals 13 squared. It does. If these don't, then these ratios won't work, because it's not a right triangle. All right, so sine of A, sine, some old hippie, right? So sine is what over what? Old hippie, what does that mean? Opposite over hypotenuse, some old hippie. So remember, A is your angle of reference. You might want to put your finger there. What is the opposite of A? 5. And what's the hypotenuse? 13, right? We'll do the decimal in a minute. So this is the fraction. That's one of the ones I'm looking for. And then let's do cosine of A. So cosine is cot another hippie. So it's what over what? Cot. What's another? Adjacent over hypotenuse, right? And so what is adjacent to A? Leg adjacent, right? It's not any adjacent. 12. What's the hypotenuse? So these both will be over the same denominator. We'll figure out the decimal equivalency in a minute. And then tan, tripping on acid. Tripping on acid is what? Opposite over adjacent. You're going to have these going over and over again in your head. So what's opposite of A? 5. And what's adjacent, leg adjacent to A? 12. So there are your fractional equivalencies. Now take your handy dandy calculator and I want you to divide them out. And I want you to go out to 4 decimal places. When we deal with decimals in trig, we tend to go out to 4 decimal places. If you look at your trig table that I gave you, isn't it out to 4 decimal places? And that's why. So 5 over 13 divided by 13 is 3846, and it rounds to 6, doesn't it? So I put a squiggly equal sign, 0.3846. And then 12/13. Anybody having trouble? You having trouble, Megan? Yeah, I'm just doing 5 divided by... Nope. And so this one is 923 what? It does round to 1, so make sure you're using proper rounding rules. And then 5/12. 4167. Why did I use squiggly equal signs? Because I'm rounding. Now let me show you something. Remember I said that I didn't know what my angle A measure is? I do now. The minute I find my sine, cosine, or tangent of angle A, I can find its angle measure. And so I'm going to show you how to do that in your chart. You use your chart to go backwards. So let's look under the sine column for a decimal that's pretty equivalent to 0.3846. So here's your trig. Bless you. Here's your sine column, and I'm looking for 3846. So 0s, 1s, 2s, here's 3s, 38. Oh, wouldn't 38 be between 37 and 39? And I'm looking under the sine column. Isn't my angle measure somewhere between 22 and 23? So what I'm going to allow you to do is tell me that it's 22.5. With our calculator, I'll show you later on your calculator how to find it exactly. But I know that my angle measure is somewhere between 22 and 23. Well, let's try it with cosine and tangent and see if I get the same thing. What's my cosine decimal? 9231. So look down here. Here's 9205. Notice that this one kind of goes backwards. It gets bigger going up, doesn't it? So again, here's 9205 and 9272. Wouldn't my decimal be somewhere between these two? And isn't it between 22 and 23? Same thing. And then my tangent is 4167. So look over here. This tangent gets bigger going down. So 4167 would be between these two here. And again, it's between 22 and 23. So can't I use any one of those three ratios to find my angle measure? That's what's fantastic about trig. All right, so let's look at B. Now, if this is approximately 22.5, what do you think this is going to be? What are these two to each other? What kind of angles are they? Supplementary or complementary? No. What do these add up to? 90 degrees, right? Because that's 90, so aren't they complementary? So if this is 22.5, what's 90 minus 22.5? 67.5. So I'll bet you when we look at our decimals backwards, we'll be looking around 67.5. All right, so let's find the sine of B. So now our angle of reference has changed. So if I were you, I'd put your finger on B. Sine, some old hippie. I would get in the habit of putting O over H, some old hippie. Opposite leg of hypotenuse is what? What's your opposite leg? 12 over the hypotenuse. Remember I showed you that these two would be the same, right? And so I know the decimal equivalency to that one because I already divided it out. It's 0.9231. And then again, my angle of reference is at B, so I'm going to put my finger at B. Cosine, question? When I do a squiggly equal sign, it's because I've rounded my decimal. That's not the exact decimal, right? Cosine of B, caught another hippie. So another hippie is adjacent and hypotenuse. So what's adjacent to B? Leg adjacent. The 5, because the 13th is the hypotenuse, right? So 5 over 13. And again, isn't that the same as my sine of A? And so we already know that decimal. 0.3846. Yes. I can't hear you. My ears are plugged. Adjacent means leg adjacent. So you have to ignore the hypotenuse as being adjacent. So when you hear opposite and adjacent, you need to realize that we're even shortening up even more that it's leg opposite and leg adjacent. And the hypotenuse is just the hypotenuse. So get used to thinking in terms of that way. And then the tangent of B, tripping on acid. So on acid, right? Opposite leg over adjacent leg. So what's the leg opposite to B? What's the leg opposite? 12. And adjacent? 5, because again, the 13 is the hypotenuse. Now this we don't know the decimal to, so we're going to calculate that. So I've got 12 divided by 5, and this time I get 2.4. If I want you to go out to 4 decimal places, how are you going to write it? And this one's actually exact, 2.4000. Now, go back in your table, and let's see if we can locate these. You're going to look under the sine column for 9231. So under the sine column is the first column. I go all the way down. At the very bottom of the column, I get hit my 7. So I have to go over to the right side, because it's split in half. And I'm up here, 7, 8, 9. 92, what am I looking for, 31? So here's 9205 and 9272. Where did we say that would end up being between? 67 and 68. Didn't we anticipate that it would be 67.5? And then notice that our cosine, which is 3846, is in between these two. And our tangent, which is 2.4, is in between those two. Okay? So put that aside and then flip it. Do you have any questions before we look elsewhere? Okay. So then, this time I'm going to give you the angle measure and ask you to find the sine of it. So I'm going to show you how to do it on your calculator. I'm going to show you how to do it on your calculator later. So today I want you to use your table. So Here's your table. I want you to look up sine of 43. So go all the way down to 43 degrees, which is all the way down here at the bottom, right? So here's 43 degrees. Which one of those ratios is the sine? 0.6820 because you're looking at the first column. So we're looking for the decimal equivalency of that ratio that gives us this angle measure. So 0.6820. All you're doing is looking it up in the table. So you find the cosine of 84 using your table. Remember, cosine is the second column. Isn't it this right here? 0.1045. Did everybody find that? So 0.1045. So you feel comfortable using your table? Forwards and backwards. So we did it forwards and backwards. Okay, then you're going to have some word problems. So let's look at this picture. I've got a ladder leaning against a building. If you don't have a picture to go with your problem, you must draw one. And this is where it's going to be hard for you because you're going to go, I'm not quite sure how to draw it. You got a 16-foot ladder, so wouldn't 16 feet go here? So the 16-foot ladder is propped against a building. The angle it forms with the ground, and that's important because they're telling you which angle they're talking about. The angle it forms with the ground. It is the ladder, right? Here's the ladder, and here's the ground. Isn't this the angle the ladder forms with the ground? If they said the angle the ladder forms with the building, wouldn't they be talking about this one? So this is your 55 degrees, so I'm going to put that in here. And it says, how far up the side of the building does the ladder reach? Wouldn't that be this right here, this distance from here to here? Isn't that how far up the building the ladder reaches? So we're going to use our trig. We know we have a 16-foot ladder. We know we have to have a 55-degree angle. I want to measure this because it's too tall for me to use a measuring tape. So you're always going to use the following formula. You're either going to have sine, cosine, or tangent of some degree equals some ratio over opposite over adjacent, opposite over hypotenuse, something like that, right? So if this is my angle of reference, is the x the side opposite, adjacent, or the hypotenuse? Opposite. So I've got opposite here, and what is the 16? The adjacent or the hypotenuse? This is the hypotenuse. So sine, cosine, or tangent is opposite and hypotenuse. Which one uses opposite and hypotenuse? Sine, cosine, or tangent? Sine. So in my equation, I'm going to choose sine. Do I know my degrees? 55, right? What is the side opposite of my degree? What do we name it? X. So you're going to put an X there. And then what's my hypotenuse? 16. So my equation to solve is sine of 55 degrees equals X over 16. Here's how you're going to solve it. Put a 1 over this and make it into a proportion. Can't we cross multiply? Don't we have X equals 1 times X? 16 times the sine of 55 degrees. Look up 55 degrees in your table and sine. So here's 55 degrees. Right here. Isn't the sine 8192? So replace the sine of 55 with 8192 and then do that multiplication on your calculator. Whoops. Hang on. And don't we get 13.12, go out to 2 decimal places, 13.12. And therefore, the ladder reaches 13.12 feet up the building. Okay, we'll talk more about this tomorrow. I have one more thing for you to take home with you today.